This board is not a picture of the process. A workflow here is a mind map board compiled into an ordered list of transactions. You draw boxes and arrows, the compiler walks them, and what comes out is the process itself. There is no second place where the real definition lives, and there is no export step. That is worth holding on to because it explains almost every design decision you are about to see. One key, no network, nothing sent. Before anything else, the honest disclaimer about this recording. There is no network connection on this page. The transaction builder is not loaded. The wallet is a single key generated a moment ago with a zero balance. Everything you are about to watch is real code, doing real work, and not one byte of it can reach the chain. Start from an empty board, new board, nothing on it but a root. We are building a supply deal. A buyer publishes an order, a supplier delivers, a delivery note gets signed, and money moves. 4 ideas. By the end, they will be about a dozen transactions in a specific order, and you will have chosen every one of them. 16 node types, 8 categories. Hold the Add button, and the type picker opens. The types are grouped by category, and each has its own color on the canvas. A task, a document, a payment, a contract, a profile, a geographic point. The type is not cosmetic. It decides which editor tabs appear, which action kinds are offered, and what kind of blockchain record the node is capable of becoming. The node is a step once it has an action. A node with a title is a node. A node with an action is a step. A typed node like this task offers the presets that belong to its type. Publish a task, bid on one, decide a result. In a moment, we will add a generic workflow node instead, and that one gets the full picker grouped by the role a step plays: trigger, gate, operation, router. Until an action is chosen, the inspector says so plainly. This step will not compile. The compiler refuses rather than guesses. Who executes this step and who pays for it? Every step has an actor. Me and you execute and pay for it. A named address, and that person does. A quorum group, a task winner, or a role that gets resolved later from a contract. A step assigned to somebody else compiles into an assignment record, and a wait for their signed answer. They do not need an account, and they never see the rest of your process. 7 kinds of arrow, 7 behaviors. This is the part that most rewards 5 minutes of attention. Branch is pure layout. Parent before child, no condition. Depends on is the workhorse. The engine waits for the target's transaction and binds its data into this step. Sends on says the same thing from the other end. Grants waits until the source has actually executed, not merely been broadcast. Blocks holds the target shut. The arrows are not decoration. They are the compile order. Carrying a value from one step to the next. A process that cannot carry information forward is a checklist. An extract pulls a value out of a step's result and names it. Take the bidder's address out of the record this wait was waiting for, and call it winner. From then on, any field in any later step can say, in double braces, context.winner. Extracts can also aggregate, counting matching records instead of taking the first. A wait is the process standing still on purpose. 5 kinds of wait, and what matters is how each one is verified. A timer clears on a wall clock or, better, a block height. Wait for event clears when a matching record appears on a watched anchor, checked against the funding signature and a distinct sender count if you set a quorum. Wait for confirmations. Clears when the previous transaction is mined. Wait for document signatures. Clears when enough valid signatures over a hash arrive. A forgery never advances the process. And wait for payment clears when the money is actually there. A branch turns a checklist into a program. Under 1,000 satoshis, skip both approvals and pay out. That is a branch. It evaluates a condition and jumps to a named step. Switch does the multi-way version. These are headless only, and the reason is honest. A browser tab has nowhere to put a jump to step 7. You can test every case right here against a context you type using the same evaluator the runner will use. Transform, foreach, sub-workflow. Transform computes new context values from existing ones and never touches the chain. Summing bids, deriving a fee from an amount. Foreach repeats a subsequence once per item in a list, which is how 40 contributors get paid without 40 nodes on the board. And a sub-workflow runs another published workflow as a single step of this one. The script step, and why it is off by default. When transform cannot express it, a script step runs a small sandbox script over the run's context. Its editor sits in the node's edit tab with a test input field, so you run it against a sample context before it goes near a real run. And note the warning, a script step will not execute on a runner whose operator has not opted in. Running arbitrary submitted code unattended is a decision each operator makes for themselves. That default is correct, not a bug. A contract is a step, not a separate product. Here's where the contract library meets the process. A contract call step picks a deployed instance in one of its methods, and the parameters can be templated from context like any other field. The badge in the compile table is the thing to read. A verified executor exists, and this step can actually spend, or it is intent only. The step records the intention on chain, and something else has to do the spending. Escrow. The money waits inside a contract. For the payment itself, we are not sending satoshis to an address. An escrow step locks the money in a contract first, and release is a separate step with its own condition. The difference matters. With a plain payment, the guarantee is that you approved it. With escrow, the guarantee is in the locking script, which is checked by the network rather than by anyone's good intentions. Compiling the contract itself offline. The contract behind that step is script source in this repository, and it has its own command line. Lint runs the precompile rules and predicts how each method will need to be unlocked. Build compiles the source to an artifact. Verify replays fixture cases through the Bitcoin script interpreter offline. So, an unlock that would fail on-chain fails here instead. Every one of these is dry by default. Broadcast is a separate flag you have to type. Compile and read the estimate before you commit. Select the root and press compile. Nothing is published. What you get is an estimate. Every step, who executes it, what kind it is, what it costs, and what will happen to it. This is the last screen before anything becomes real. So, read the table rather than the total. Whose money the total is? Try the cost column is what each step costs the actor who runs it. Miner fee plus anchors plus whatever value it moves. And the estimated total is yours only. The line underneath breaks out what every other participant is signing up for. Because a step assigned to somebody else is not free. It is just not free for you. The most consequential setting on the page. At the bottom, you choose where this runs. My outbox means steps land in your queue one at a time. You approve every transaction. No third party is involved at all, and it stops the moment you close the tab. A headless workflow means the definition is signed, published, and executed by a runner that keeps going while you sleep. That is the whole trade. Nothing is delegated, or deadlines are honored overnight. You cannot have both. Rails, because runs while you sleep needs boundaries. Runs while you sleep and can spend my money is a combination that needs limits. And here they are. The payout budget per transaction. Anything above it pauses for manual approval, and the effective cap is the lower of yours and the runner's own. Require proof, so each confirmation is verified with a real Merkle proof against independently fetched headers, instead of one API's confirmation count. Admins who may pause and resume, but never kill or export. A rules library of named conditions, and a context schema that turns a payout, silently resolving to an empty address, into an error at compile time. All of them are signed into the definition. The runner honors them because the chain says so, not because it is being polite. Simulate what it would do, not what it would cost. The estimate tells you what the process would cost. Simulation tells you what it would do, and both are free. Simulate walks every step with 0 broadcasts. Transactions get a synthetic identifier. Waits ask whether the condition is met, and branches and transforms are evaluated for real against a mock context you can edit. Then it highlights the path that actually took over the flow diagram, so a branch that never fires becomes visible instead of assumed. Now compile it for real. Same dialogue. Target set to my outbox. Compile. The graph is walked. The order is resolved from the links. Every templated field is left as a placeholder to be filled when the value it refers to actually exists, and each step becomes a draft transaction. That is the compile. A graph in, an ordered queue of unsigned drafts out. The drafts. Read one before you believe any of it. Here is the queue the compiler produced, and this is the moment to be skeptical. Each draft carries its record. The anchors it will pay 1 Satoshi to, so the record can be found, and its cost. Open one, and you can read exactly what would be written. Nothing is signed, nothing is sent, and in this harness, there is no code path that could send it. The gate and why it is manual. Every draft is still waiting for a decision. Approve, sign, broadcast, 3 deliberate acts, and none of them happened here. This is the boundary the whole design defends. The compiler is allowed to decide what should happen and in what order, and only the keyholder is allowed to decide that it happens. The same process, seen by the engine. The flow view is the graph as the compiler understood it. Lanes by actor, the branch and its cases, the waits and their timeouts. If what you see here does not match what you meant, the board is wrong and no amount of running it will fix that. It exports to a standard notation too, for the people who will never open this application. What running it would look like. In run mode, each node carries a live badge. Waiting, done, failed, and every completed step links to the transaction that proves it. That is the part which is genuinely different from other automation tools. The execution history is not a log in somebody's database that you were invited to trust. It is a chain of transactions anyone can open. What you actually learned: a board, node types, and actions. Actors, 7 kinds of link, extracts, 5 kinds of wait, branches, scripts, a contract as a step, an escrow holding the money, and a compile that ends in an estimate and a queue you still have to approve. Build it wrong, and the compiler tells you at the estimate. Build it right, and the only thing left between the plan and the chain is your own signature.